This picture is taken from Montgomery Statistical Quality Control textbook. I showed in one of the video how to calculate these probabilities. In this video, I will show you how to calculate these probabilities. So in this one previously, we have shown you if the process is centered. So you have a coffee machine that is designed to produce coffee at 180 degree Fahrenheit, and it is producing at that specification, at that target level. Now something happened to the machine. It's probably this is getting old, it's drawing more current and producing coffee at higher temperature than 180, it's maybe 200 degree Fahrenheit. However, typically the case for a coffee machine is usually it does not produce enough heat over few hours of use. So imagine that it now producing 1.5 standard deviation less. So not producing 180 degree Fahrenheit is somewhere around producing maybe 160. Whatever it shifted to the left, 1.5 standard deviation shifted to the left. Now how do we calculate? Now still we want to drink coffee at 180, so how many cups are we going to actually produce using this machine within a specification limit? You look like that -1 standard deviation, that this is our 180 and maybe this is 190, 170. So within that one standard deviation, how many of them are within a spec limit? If you look at these, that 30 is within the specification limit. So the number significantly decreases. Before it was 68, now it is 30. So within this, between these two lines. So still we have the same specification limit. We want to drink the same coffee. However, the machine coffee producing distribution shifted to the left, meaning that most cups are now coming less warm than before, so shifted. Now let's go ahead in Excel to do all the calculations. So our lower specification limit, I'm going to make this cell wrap text, so I got some more space to work on, and then upper specification limit, and then I have so I have the same limit. The limit did not change. Let's copy this all the way up to 6. We want to see up to 6 standard deviation. Now even though this specification did not change, the line, if you look at the area under the curve in that picture that I showed you from Montgomery, the distribution is right now here, and we are trying to find the area between -1 to 1 under the new distribution. So how do you find that? Now Excel does not know that your distribution had shifted to the left. You will have to show that. Now if you look at this is 1.5 shift, and then if this is 1, then this will be 0.5 plus 0.5 with respect to the new distribution, and then this -1 plus 1 total 2, and then 0.5. So this point will be 2.5 under that new curve. So the new values for this will be 0.5, this one will be 2.5 corresponding. So the 0.5 corresponds to specification limit -1, and then 2.5 correspond to spec limit 1. Now I would like to name this as X lower and then X upper. Now if you go back to that curve again, the picture, this x-axis is called typically the x values, and the y-axis is the frequency of any probability distribution or probability values, probability frequency. So let's go back. Now I would like to make a formula so that I don't have to calculate each of these manually where their new corresponding numbers are. So you see that minus 0.5 becomes 0.5, 1 becomes 2.5. So I'm looking at a formula something like this minus that new shift, like that. So if you go like that, see, so it is shifting, it's shifted to the right, you just don't use it. So whatever is shifted, you subtract that, the easy way to remember. If it's negative shift, just use a parenthesis, so basically eventually it's gonna be plus. Now we copy this all the way down. Now we want the area before the x lower and then area before the x upper. So I can use the same norms dist function in Excel is for a standard normal. So this one, copy that to the right, copy that to the down. So this is basically calculating the area all the way up to that 2.5 from the left, all the way from the left to the 2.5. Remember, normal distribution never touches the x-axis, so it goes to all the way to infinite. And when we write norms dist any value, it calculates a cumulative probability from the left to that point. Now we want to calculate the area between. I want to go back to the curve again. So I have probability associated with this line, this specification limit, 2.5 for that curve, and then probability associated with this value -1, that is 0.5 for this curve. So if I subtract the area up to 0.5 from the area up to 0.25, then we're gonna find this area. This is what we want under the new curve. So let's go back to Excel, subtract that. So that will be our percent conformance unit. So it's gonna be equals this minus this value. So 0.3 out of 1 product will be in conformance. So let's present this in percentage so it makes more sense for our brain, I guess. Parentheses times 100 will produce things in percentage. So that's in percent conformance. So let's calculate percent non-conformance. Non-conformance. So percent non-conformance is 100 minus the conformance. So now non-conformance in numbers increases because the machine is not producing as it's supposed to. Now, because these numbers are too low, typically it is presented in per million. So non-conformance per million, it's called ppm. I'm gonna do a little bit this, so I got some more space. Let's do this. Non-conformance per million. So I can simply multiply this by million. Now remember, we already multiplied by 100, so I'll have to only, if I multiply by 10,000, it's gonna be actually within millions. So now 3.4 products out of a million will be defective. So there will be coffee that is not within its specification. Now let's calculate the CP value. Now for non-centered process capability is expressed as CPK instead of CP. Now CPK has two it uses two formulas to calculate that. Now let me copy the formula first. So for it calculates CP value based on upper spec limit and also calculates CP value based on the lower spec limit. So it calculates CPU and CPL, and then it the CPK is the minimum of these two. So my spec limit is still same. So let's calculate that CPU, which is spec limit minus the mean. Now right now my mean, you see that X bar, that's my sample, that's my new distribution. So that new distribution has a mean of 1.5 sigma divided by 3 sigma. Sigma cancel out from the numerator and the denominator, and copy there, and this is gonna copying that upper spec limit. However, I think this one is actually lower, this one is upper spec limit. So now for the lower spec limit is the other way, is 1.5 minus the spec limit, so like that. And the upper spec limit is this minus 1.5 divided by 3, so that's fine. Now copy this all the way down. I'm gonna move this, copy this. Now CPK is the minimum of these two values. So right now you can see the CP value has significantly changed. So this is all about the off-centered process capability, off-centered process capability